while I'm out here and I got the camera fired up, I guess I'll show you this. Latest developments on this thing. Probably looks pretty much the same as you'd seen it before, except I added this. Before I was like burning my fingers adjusting this needle valve. Although this needle valve here is almost superfluous, because I control the stove with this needle valve on my fuel bottle. And I had ditched the copper generator loop for one that I made out of brass, hoping that it would be a little more durable. But even this one has some durability issues. After it's been used, the heat anneals this so much that now it's very soft. I can bend it around. Not quite sure what, if anything, I can do to remedy that. I've got, instead of a cotton wick, I've got just a whole bunch of strands of copper wire twisted up and shoved through there. In my previous video on this here thing, I had speculated that the cleaning cable in commercial stoves that use a generator loop was to act somewhat as a wick and also to displace the empty volume in here. I kind of ditched the wick notion. You don't need a wick to draw fuel in here, because you're force feeding it with a pressurized bottle. But I was thinking, in a previous burn of this, I witnessed a little drop of fuel sputter out and land on the top of this burner plate, and it kind of beat it up and buzzed around on top. I kind of chuckled, thinking it was a good example of the Leidenfrost effect, where it, rather than just vaporizing and evaporating almost immediately, it sat there buzzing around because it wasn't getting good thermal contact on the plate, because it was riding around on a cushion of its own vapor. It actually wasn't touching this thing. And I'm thinking that the same thing could happen inside the generator loop. That this liquid fuel comes in contact with the hot material, and it's so hot that the Leidenfrost effect doesn't allow good thermal contact, and the fuel just zips through here without even touching this thing. And so now I think that the cable running inside this generator loop is to take up the extra volume and to sort of stifle this Leidenfrost effect. But now I'm running into kind of a different issue, and I'll start it up here. Okay, got this valve a little open, doesn't really matter. And I'm going to crack my fuel bottle valve open, and I'm going to spill some fuel. And maybe you can see that. There we go. There we go. Okay. I'll go ahead and light that fuel and let it preheat. I had also experimented with, rather than having a loop going around the perimeter of the burner, having one just come up and over and down. Just a single pass. That one preheated much better, but it didn't run very well. I think I wasn't giving it enough time in the generator loop, the fuel enough time in the generator loop to form good vapor. It's chugging away, although you probably can't see. alcohol flaming off. You can see the jet kind of sputtering because it's connected to the vapor loop, and the vapor loop is generating pressure, and I get little squirts. It's actually about ready to overflow there out of the burner cup. This burner cup, by the way, is a little stainless steel cup for, let's see, they sell them at Walmart. They call them condiment cups. You know, you put ketchup or whatever in them. Ooh. You can see where my fuel line connects to the generator loop. It's getting pushed down, the liquid, out of the loop as my generator loop heats up. Here, when I think it's hot enough, I think it's hot enough. I'm going to crack it open. Here we go. Now that it seems to be up and running, the problem I was referring to will begin here shortly. See that? That's surging. Shut it off. Yeah, so the problem I'm having with is this strange surging going on. You could see this fuel line kind of shudder under the pressure. You could also see this thing flexing a little bit. I guess it's a good demonstration of how a Bourdon tube works. As the pressure in this coiled tube increases, it'll try and straighten itself out. So as the pressure increases, it'll try and the radius will open up. But I don't want that to happen. I don't know if I need like a check valve in here. I'd like to not add any more complicated pieces to this thing. Oop. Mailman's here. From what I've seen, demonstrations of certain liquid-fueled stoves, they do kind of do that as well. But maybe this fuel line is too flexible and it can swell up too easily. Maybe I'll try a larger orifice. Maybe some of that surging pressure will come back out the burner instead of shoving the fuel back in my fuel line, because I'm almost getting kind of like a vapor lock issue where it's forcing the liquid backwards out of this thing, and it's keeping the liquid from getting back in, that vapor pressure, which if all I have is vapor in here, this will quickly get much hotter if there's no fuel being vaporized in here. That vaporizing fuel kind of cools this thing down. If that's not occurring, then this thing will get much hotter, to the point where once the pressure in here drops enough to let the liquid fuel flow back in, it's now too hot and it boils and shoves it back out. Maybe that's what's causing the surging, but I'm not sure how to correct that.